This is sign test for the first one. Second for Man-Whitney. Why Man-Whitney? Anyone? Anyone from that side? आप लोग बहुत शांत बैठे लग रहे हो. Why Man-Whitney in this situation? Anybody? No, not anybody. आप दोनों लोगों में से कोई. Why we are applying Man-Whitney in this case? What warrants, what guides you to applying a Man-Whitney U test? That the sample should be. मैं वहाँ आ जाऊँ. That the sample should be from independent groups. And what is independent in this situation? Specialties are different. Palliative and medicine. So one can see that depending upon what type of data you have, that specific test needs to be done. In the same way, when you want to do for 3 different specialties, Kruskal Wallace independent sample, say medicine, say palliative care, say critical care, different sample. That means samples taken from 3 different sites or from 3 different populations that can be there. Longitudinal samples, Friedman, and for Wilcoxon ransom test. This is what is called as pre and post for 2 specialties. Wilcoxon sign ransom test, and then status of response as pre and post chemotherapy among breast cancer patients. That is a McNemar test. Now in McNemar, what I will wait it. So this is when many of you would have used SPSS. So when you go to analysis tab and you click on this non-parametric and this, it looks very good. SPSS mein everything data is there, kit, everything comes in a quick way. But the real learning, the real thing starts whatever you get after that. Because the way you get it, you can't report it in your thesis like that, or you can't report it as that table in your paper. You have to modify, you have to customize the output to meet the requirement for your thesis and work, and that comes over a period of time with experience and other things. So if you want to do some non-parametric with an R software, which is an open source software, here also one can do a non-sign test or a Wilcoxon test, Man-Whitney and Kruskal by this. And so this is one example. Don't go to the equations. What is important, I will just try to focus. Don't go on equations. Please shut your eyes for. इसको ऐसे आप लोग बंद कर लेना. Like सॉरी इक्वेशन दिख गया, इक्वेशन देखने की जरूरत नहीं है. What exactly I want to understand from you is that just understand that how it has been done. So this is an example of where resting energy expenditure for patient with cystic fibrosis has been taken, and handling individuals matched on age, gender, and height and weight. So what is happening? These are the pairs, their values are being taken, and we have only taken the difference. And then we are saying whether it is plus or minus. So values of 1 in this way, and values of this in another way, and just the difference, and this plus and minus. So what is happening? We have 2 columns roughly. Means one is this column and other is this column. We have taken the difference, and we have on the basis of that just pointed at each cell position whether it is positive or negative. That means whether it is improved or deteriorated. And then we did some calculation, and we came out with a value which is situated at this is 2.5. Now, do you all people have the concept of normal distribution? Yes. What is normal distribution? Well, it's a very vague question to ask, but just at a conceptual level, what you understand by normal distribution? When we say that the population is normal,
the data are equally distributed within the bell-shaped.
Yes.
Line
एक जगह. But is it technically possible in the real world to have all the 3 values at the same time?
No.
Not at all possible. Not at all possible. Even if we count our steps like this and measure the distance, that will also vary. Nothing is so precise that everything can be the same at the same point. It has to deviate somewhat plus minus something. So mean plus minus 1 ST, 2 ST, and 3 ST. That is what happens. That means what happens now? What is this mean plus minus 1 ST, 2 ST, and 3 ST?
Left side or right side.
So what does it? Why it is important?
Standard deviation and mean between the.
Majority of the data would be 33
percentage of
SC1, and some data would be in SC2.
Okay.
68, 95, 90.
Yeah. So we say 68% of the data within mean plus minus 1 ST, and 95% within mean plus minus 2 ST,
2 ST.
and within mean plus minus 3 ST about 99.95. Why not mean plus minus 4 ST, 5 ST and 6 ST? Why statistician only stopped at mean plus minus 3 ST? What came into their mind that something is important only for 1 ST, 2 ST and 3 ST? Why not 4, 5, 6, 7, 8, 9, 10? Any idea on this?
Minimal data would be there. Minimal data would be there in that range.
Minimal data would be there in that limit. And anything else? What you said is technically correct. I want to go a step up. Yes, you had something in mind to say. So you are raising hand. I thought you were saying. So you can shift your place to that side.
There can be chances of 5% error.
Yes, there is always a possibility of an error.
Error.
Outlier.
Now, if I ask you one question, that of the three, no, what are these called as? Mean plus minus 1 ST, 2 ST, 3 ST. What are these?
The standard deviation, if it is more than 1/3, it will not come under.
That's fine. My question is, what these mean plus minus 1 ST, 2 ST and 3 ST called? ये हैं क्या? इनको कहते क्या हैं?
क्लासिफिकेशन हो गया, डिवीजन.
Error.
Look, every one of you is more or less correct, but I am looking for the exact thing. That what exactly this mean plus minus 1 ST, mean plus minus 2 ST and mean plus minus 3 ST are called?
Ranges of.
No. Range is minimum and maximum. Somebody said confidence interval. Who said it? It is 50% correct, 50% incorrect. What is that remaining 50% I want to know? No, degrees of freedom is n minus 1. Something else. It is called as confidence. आपको बताना है, मेरे को नहीं बताना. It is not called confidence interval. Let me be very frank on this. It is called something else, but of course it has a prefix of confidence.
Please tell the answer.
Huh? I can say, but there has to be some joke and some element of mischievousness and other things. Please, any guess? Anyone?
Confidence level.
No, confidence level is alpha. 1 minus alpha is confidence level. Confidence तो वो है, जितना तो confident है, लेकिन वो अगला क्या है interval की जगह? That is important.
We are not confident in telling.
Okay, so आप लोगों ने हारी मान ली है. They are called as confidence limits.
Okay.
They are called limits. They are not called interval. And now why it is not called interval? Because interval में आप लोगों, for interval we need standard error, not standard deviation. So your confidence limit is based upon mean plus minus 1 ST, mean plus minus 2 ST and mean plus minus 3 ST. And these are called as confidence limits under a normal distribution theory. But when we say mean plus minus 1 standard deviation, standard error, 2 times standard error and 3 times standard error, that becomes the confidence interval. Now why standard deviation and why standard error? Because in confidence limit, what you are trying to say that something is normally distributed. That means the population or the sample from which that population has been taken is following a normal distribution. But whether the sample that you have taken from that normal distribution is following a normal distribution or not, it may or it may not. That means it will be prone to some error. And when we calculate the standard error, then only we can go about creating the 95% confidence interval. So standard deviation helps in giving the confidence limits, and standard error gets you in the calculating the confidence interval, because that is based upon the distributional assumption of your population. That's the difference. Any more confident you need to be on this? Okay. So that's one situation, that how this is the demerit of this test, that it is only depending upon what is called as this. Now why I raised this issue of this confidence limit is because mean plus a little bit more discussion. Now mean plus minus 1 ST, 2 ST, 3 ST, which is the best limit and why? Okay. Objective type question. Which of the following confidence limit is the best? ABC, mean plus minus 1ST, mean plus minus 2ST, mean plus minus 3ST. And answer D,
None of them.
none of you.
Answer C.
Huh?
C.
C.
Mean plus minus 3ST. How many of you say mean plus minus 3ST? भाई हाथ तो उठा लो कोई साथ किसी में तो कोई हाथ उठाएगा मीन प्लस माइनस 1SD अब हाथ ही नहीं उठ रहा है ओके एनीवन विद द मीन जो नहीं भाई आप 3 में भी उठा रहे हो 1 में भी उठा रहे हो एक ही में उठाओगे एंड देयर इज अ स्पेसिफिक रीजन फॉर दिस डिबेट एंड मतलब व्हाई I say mean plus minus 2SD is important, that is, and why it is important. Anybody, any idea on that?
96% is comes
Covered.
in the
So what is happening that if we take mean plus minus 1ST as an ideal limit for any population, what is happening? We are ignoring 1/3 of it. Because what is happening? Mean plus minus 1ST is covering about 68% of our observation. And rest 32% is being removed, not being taken into consideration. And the loss of 1/3 of information is a large chunk. And if I try to do mean plus minus 3SD, what is happening? Practically, we are trying to cover everything in 1 minute. That means everything is covered. That's why we can't go beyond mean plus minus 3SD because we have to be reasonably certain that some amount of variation may not be captured at all. Some element of error would be there. So we want a limit which should be reasonable. We should not ignore large chunk of the data, but also it should not include all of the data because variability is inherent. So that's why mean plus minus 2SD. And on the basis of that theory, there is a normal probability theory make value. There is a value what's called as 1.96 as a critical value, above which you will say that there is statistically significant result. And this value you can see this is 2.5. Which is greater than 1.96, so you will see that there is a statistically significant result in this situation. What you will deduce that the proportion of individuals whose this difference of plus and minus is not the same. They are different. You cannot say with this experiment that exactly in equal proportion of individuals there was plus sign and there was negative sign because you are getting a significant result. So that's why I told don't go to this math, just the situation and the last thing. Come to the next situation. A person is suffering from say cystic fibrosis and we know that's an important life-threatening disorder for digestive system and some cardiac elements also, and reduction in their FVC and ML was noted. The difference was there. Now what we do in this is, first of all, we take the difference. You just take the difference with a sign. This is first step. Second step is you rank these values ignoring the sign. So what will happen that on these two values, first of all you take the difference and then you rank, you create more columns of rank, and then you can see that this is 11, minus 15, 42, 101, 106, 113, 152, 155, so on. So it is arranged from ascending in the ascending order. But we are having a minus sign here. What is happening if we rank them in one order? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a situation where every value is not repeating. You are not having a repetition. But if we do have a repetition, we take the average of the rank. For example, suppose if this observation, this would have been come 6, 6, it would have taken 6.5 and 6.5. Some average has to be done if there are ties. So once this rank has been done, you attach the sign related to this difference. So you can see for this second data point we have negative value. For 8th data point we have the negative value, and for 11th data set we have the negative value, and you minus. So what is happening? That's why it is called as signed rank, because what is happening after taking the difference, we are ranking them according to their sign. That's why it is called as a Wilcoxon signed rank test, because after taking the difference, we are ranking not on the pure rank but on the basis of the sign also. That means we are taking into account the magnitude as well as the sign also. So we do some calculation again. Don't borrow about the formula again. just you can see this value is 2.10. Yes.
You arrange this in ascending order, or is it by?
I have arranged
do
them.
it before.
I have done it before. Just for the purpose of illustration, I have arranged it in that way. But in situation, you will not get that. But you will have to play with the data to arrange it. So here it is 2.10. Again, what is the significance? There is it. This value again is greater
More
than
than
the absolute
1.96.
value of 1.96. It is significant. And what is the deduction? That the median difference across the two groups is not 0. It is different from 0. So that's the difference. So that's why this situation you can see that why it is called as a Wilcoxon signed rank, because after taking the difference we rank according to the basis of the sign. So it's an improvement over the sign test. That's where the difference is. Now suppose another situation, that is what is called as a Wilcoxon rank sum test or a Mann-Whitney U test. Now in this, what is happening? We are taking a situation of what is happening. There are children who are suffering from phenylketonuria, and we know that phenylketonuria is this element is a genetic disorder in which it is not it's an inherited disorder in which individuals are not able to break down the amino acid of phenylalanine, and because of which they can get an intellectual disability or some intellectual disability or mental retardation or some any type of cognitive disability can occur. So their normalized mental age score from 2 samples of children was measured, and this was being measured on some value what was taken their normalized mental age score with a low exposure of phenylketonuria and a higher exposure. So these are independent groups on the basis of the exposure level of phenylketonuria, and then this is one independent sample, this is another sample, and this is rank and this is rank. So you can see the smallest value is 28, 1. And the highest value is, say, it would be like 55. That is 57 years. So that is here. So what is happening? Whatever data is there, you mix everything, you arrange them in the ascending order, and then identify to which group it is belonging. For example, if I calculate the age of all of you, and I arrange them in an Excel in ascending order, and then I rank them 1, 2, 3, 4, 5, 6, 7, 9, 10. May about say 35 into of you, and then I put them ranking. I say M for male and F for female, or 1 for male and 2 for female. So for separately I will calculate, for male I will calculate the rank, sum of the ranks, and for female also I will calculate their mean ranks, and on the basis of that we will do the statistical test, and then you can say here did some calculation, it came out to be 1.32. It is significant or insignificant? It is, because it is less than the critical value of 1.96. So that's one situation. Now Kruskal-Wallis, now up to this point the application of nanoparametric looks to be slightly easy, but after this it's a little bit more complicated when Kruskal-Wallis test or more Friedman test or other things come into account. So this is a Kruskal-Wallis where you have 3 or more independent groups. So it's an extension of Overman analysis of variance. You take the observation, just I'm demonstrating, you take some values are there, one can say any value you can take it. Then this is first group, this is second group, this is third group, this is fourth group. We calculate the rank, that we rank each of them 1, 2, 3, 4. So what is happening? Each and every individual is being labeled according to which group it is belonging and what is its rank. We calculate individually some values in this way, the observations and their sum, and then we calculate, and this is what is, and this value is called as Kruskal-Wallis of H. This is what is called as 140.2, and it follows it is approximately followed a chi-square distribution with n-1 degrees of freedom. So for n-1 degrees of freedom, the chi-square value is 3.682, and this value is 140.2. You can see that significantly higher. We will deduce that the median of the across the two groups are not the same, but they are different. So some of our publications, and just to tell how we report in the paper, this is one of our paper in experimental and molecular pathology, and it was we know that there is a resistance to chemotherapy for AL patients, and this study investigated different drug resistance and apoptotic genes in 85 patients of AL and 40 patients of lymphoblastic leukemia, and this is how the results are presented. So you can see here Now, why I have deliberately used this presentation as this slide, because you can see here what we have done, that we express the gene expression level in terms of mean plus minus HD. That means the original data form. And you can see the value here, say 2.71, 1.77. Now, just by examining the exact value of mean and standard deviation, it is possible to draw some conclusion about the nature of your data. What it says that if the value of standard deviation is 50% or more than the value of the mean, it is suggestive of a slightly skewed data. That gives a very rough guess to start with. And you can see here all these values. Now say this for MDRN1, 2.26 plus minus 2.65. Your standard deviation is higher than the mean. Large amount of variation is there. Then see this value 0.06 and 0.11. Again higher. 2.59, 3.13. Higher. 0.13, 0.13. Almost the same. In the same way you can see here 1.1, 1.3, 0.8, 1.2, 1.5, 1.6, 0.1, 0.1, 0.8, 0.8, 8.2, 8.6, 2. So you can see that the value of standard deviation is slightly higher than the value of the mean. So, but why we reported mean plus minus HD? Because that's to retain, to preserve the original form of gene expression level among the patients of AL and ML. Now, in the same way, but when we calculated the p-value A, you can see p-value is calculated using Mann-Whitney U test. So what we did in this, the descriptive statistics remained the same in the original form of the gene expression level, but the test of significance got changed because of the distribution, because of the more skewness in the data. So that is the purpose of demonstrating to you all that how one can report this in this situation. This is another one of our paper in which we studied the role of androgen receptor in epidermal growth factor receptor in locally advanced breast cancer patients before and after chemotherapy regimen. And in this, a slightly different way of presenting the result. Now, what was happened that this is the descriptive statistics for this gene expression level in pre and post, their mean plus minus HD. And then pre and post, what happened? When I showed the example, I said -2, -10, -7, -19 was one variable, and when was positive. So what will happen? When you subtract the value of baseline and end line, either it can be 0, it can be positive, or it can be negative, depending upon the magnitude. So when